Hello student, today we are discussing how we will draw a signal flow graph from a given block diagram. Okay, so let's start our discussion. Okay, so while we want to draw a signal flow graph from a given block diagram, the adjacent summing points and takeoff points are represented by a node and the block transfer function is represented by a line joining the respective nodes. Okay, and the direction of signal flow is indicated by an arrow on the line. Okay, however, in the direction of signal flow, if in the direction of signal flow, if a takeoff point precedes a summing point, then such point are represented by two separate nodes, not a single node. Okay, if your takeoff point precedes a summing point, then such point are represented by two separate nodes with a transmittance of unity between them. So we take an example to understand this. So this is our first example. Okay, so here first arrow indicate the input. Here R is missing. Okay, so this is R. And the output is represented by C. C is missing here. Okay, so see the example here. This summing point means first summing point, and this takeoff point we can represent by a single node. Okay, same after G1 block, this summing point and this takeoff point, we can represent these two by a single node. Okay, from before G1 this takeoff point and this summing point we can represent by a single node, and after G1 this summing point and after summing point this is takeoff point, these two are represented by a single node. Okay, so remember this. Okay, so if this is our block diagram, then we can draw a signal flow graph from this block diagram, and our signal flow graph is this. Okay, next come to next example. So students, see here you see before G1 block, the summing point and the takeoff point, these two we can represent these two by a single node. But after G1, you see after G1 first is takeoff point and then is summing point. Okay, so we can represent this summing point and this takeoff point by a two separate node. Okay, by two separate node and with the transmittance of unity between them. Okay, so here see the signal flow graph of this block diagram. Understand? Okay, so in the direction of signal flow, if a takeoff point precedes the summing point, then such point are represented by two separate nodes. Okay, and with the transmittance of unity between them. Clear? Now we take another example. Okay, so here this is our block diagram. So from this block diagram, how we can draw signal flow graph? Okay, so here see there are how many nodes are there? So see there are first RS is first node, ES is second node, X1 is represented by third node, X2 is represented by fourth node, and X3 is represented by fifth node, and CS is represented by last node, means sixth node. Okay, so see here, So see here, all the summing point is represented by a node, all the summing point and all the take up point represented by node. Okay, so now connection, now see how we can connect it this node. Okay, so see, ES means this comparator signal. So ES is based in ES, there are two signal is coming, one is RS, okay, and another one is H3, and this is negative feedback, that's why minus H3. Okay, next you see in X1 there is also two signal is coming, first is G1 and second one is minus H2. Okay, next see X2. So in X2 there is two signal is coming, first one is G2 and second one is minus H1. Okay, then see X3. So in X3 there is single signal is coming, that is G3. Okay, next from X3 is one signal is coming, one signal is going to CS. Okay, so this is our complete signal flow graph of this block diagram. Okay, now we can see how many forward path is in this signal flow graph. Okay, so there is, you see there is only one forward path, and this is G1, G2, G3, G4. Okay, so for first forward path is mentioned by P1. Okay, and identify how many loop are there. There are 3 loop. Okay, so first loop is your G2, G3 means this is our one loop. Okay, this is our one loop. This is our one loop. And this is our second loop. Second loop is G3, G4 minus H1, and third loop is this. This is our third loop, means G1, G2, G3, G4 minus H3. Okay, so see here, first forward path is this. First forward path is this. So this forward path touching all the loop, that's why del 1 equal to 1. Okay, so you put this P1 del 1 divided by del value in transfer function, that is Mason's gain formula. CS by RS, then you find actually this is T. So you find the transfer function of this signal flow graph. Okay, now come to another example. See how we will draw signal flow graph from this block diagram. Okay, see here how many nodes is there. There are 1, 2, 3, 4, 5, 6, 7 node are there. Okay, so see here how many summing point. Summing point are 4. X1 first is E, then X1, X2, Y1, Y2. No, sorry. So summing pointer, how many summing pointer there? Summing pointer, 3 summing pointer there. Okay, so the 4 summing pointer there. So first summing point is represented by E. Okay, second summing point is represented by X1, third is X2. Okay, and this Y1 and Y2 is take a point, and the last summing point actually represented by CS. Okay, so now we connect this node. So see how they are connected. Okay, so for ES is a combination of RS. Once in ES, one signal is coming from RS and another one is coming from CS. Okay, next see X1. In X1, one signal is coming from ES, another signal is coming from Y1, And third signal is coming from y2. See x2. No, next x1 is connected by y1 by transmittance G1. Okay. Now see x2. In x2 there are three incoming signal. First one is coming from E, second one is coming from y1, and third one is coming from y2. Then there is one outgoing branch from x2. Okay, so for this outgoing branch is go to the y2. Okay, and now see from y1 and y2 there are two signal is coming, and this is going to CS. Okay. Now see how many forward path and how many loops are there. So see, there are 7 loops are there. So identify these 7 loops. Okay, so first loop is obviously this G1 minus H1. Okay, okay, then second loop is this G2 minus 1. Okay, next third loop is your G1, this G1 minus 1, G2 and 1. Okay, and fourth one is minus 1, G1 1 and minus 1. Okay, this is fourth loop. And fifth loop is minus 1, G1. Okay, see, minus 1, then G2, then 1, then minus 1. This is fifth one. And sixth one is 1, G2, then 1, then minus 1. Okay, and last one is 1, G2, 1. Okay, no, this is not 1, G2, 1, G1, 1, minus 1. Okay, clear? This is our 7th loop. Okay, now find the non-touching loop. There are two non-touching loop. There are two non-touching loop. So find how many two non-touching loop are there. There are how many combination of two non-touching loop. So see, there are 3 such combination of two non-touching loop. So first one is first combination is G1 minus 1. This loop and this loop are non-touching. Okay, next is minus 1, G1 1 or minus 1, means minus 1, G1 1 or minus 1. This and this G2 minus 1. These two are non-touching. Clear? Next is 1, G2. Okay, G2, then so here see, from non-touching loop and the 7 loop, we see there are 7 loop, and there are 3 such combination of two non-touching loop. So from this we can calculate this del. Okay, and now we will find how many forward path is there. There are 4 forward path. Okay, actually 4 forward path. there are 4 forward paths. The first forward path is this -1 g1 1. Okay. Second forward path is -1 g1 -1 g2 1. Okay. Third forward path is 1 g2 1. And last forward path is 1 g2 1 g1 1. Okay. So clear? There are 4 forward paths. Now we will find del 1, del 2, del 3, del 4. So if we consider the first forward path, this forward path, so this forward path cannot touch this loop. This forward path do not touch this loop. Okay. So here we put 1 minus the gain of this loop. So this loop gain is minus g2. So that's why 1 plus g2. Okay. Now if we consider the second forward path, the second forward path is this -1 g1 -1 g2 1. So this forward path touch all the loop. That's why del 2 equal to 1. Now if we consider the third forward path is this. Okay. So this forward path do not touch this loop. Okay. So here del 3 equal to 1 plus gain of this loop. So 1 plus g1. Okay. Now we consider last forward path. Last forward path is 1 g2 1 g1 1. So this forward path touches all the loops. That's why del 4 equal to 1. Okay. So if we put all the values of p1 p2 p3 p4 del 1 del 2 del 3 del 4 and del, then we find this is our transfer function of that signal flow graph. Okay, clear?